We know that any liquid under pressure has a certain force or energy, and it is this energy that is utilized in the fluid coupling. Here we've set up a model of a fluid coupling on a simulated drive shaft to show how the fluid coupling is positioned between the engine, the transmission, and the drive wheels. To see how the fixed mass of liquid inside can be used to couple the engine to the drive wheels, let's take a look at this bowl filled with a liquid, in this case, oil. When the bowl is revolved, the clinging quality of the oil causes it to revolve also. As a result, the centrifugal force set up causes the oil to move from the center to the outer circumference and creep up the sides of the bowl. By attaching a set of vanes which radiate outward from the center to the bowl, we can increase the tendency of the oil to rotate with the bowl. This causes more energy to be transferred from the bowl to the liquid. Now let's see what happens when we add a second set of vanes. Notice that this set is not connected to the bowl or lower set in any way, but can move freely. The shaft, which has a marker to show rotation, can be likened to the drive shaft of a vehicle. The upper set of vanes doesn't revolve at first because the bowl isn't imparting enough energy through the oil to overcome the resistance of the hand holding its shaft. As the speed of the bowl increases, more energy is transmitted, causing the upper set of vanes and its shaft to revolve, despite the load exerted on the shaft by the hand. This pressure of the hand can be likened to the load the engine must move. The lower set of vanes is called the pump, the upper set, the turbine. We've seen the transmission of power without a mechanical connection between the two sets of vanes, but just by means of a fixed mass of moving liquid. To put this method to work on the drive shaft of a vehicle, which instead of running from the bottom to the top runs horizontally, from the engine to the drive wheels, the fluid coupling must be a sealed unit and have a leak-proof housing. Here's the actual fluid coupling, which has been disassembled so you can see inside. This is the driving member which connects to the engine. It's called the pump and has straight vanes radiating from the center to the rim. Note the addition of this ring. Its purpose is to better control the flow of fluid within the pump to the driven member. For that reason, it is called the guide ring. And this is the driven member, which connects to the drive wheels. It's called the turbine and is constructed almost identically to the pump, including the straight radial vanes and guide ring, which better directs the oil back to the pump. By using this pipe cleaner, we'll be able to see how the centrifugal force sends the fluid from the pump to the turbine and back again. This pipe cleaner, representing the oil in the fluid coupling, is now ready to show this motion, which is called the vortex motion of the oil within the fluid coupling. Because of the guide ring, uniform, non-turbulent vortex flow results, increasing the efficiency of the coupling. Now we know that there is this direction in the oil within the fluid coupling. But we also know that the pump is turning, so there is another direction that the oil takes, which goes this way. Therefore, the effect of this dual motion in the oil would be roughly in this direction. Because of the centrifugal force and the turning of the pump, the actual flow of oil is like a continuous corkscrew. that goes round and round inside the fluid coupling in operation.